Okay, let's come back to our own slide. Hopefully everybody have a little bit of understanding, little bit of brief view of what does this machine looks like. So remember, we have the radiation source just now, and then we have the atomizer or absorption cell, and then we have the sample introduction system, the one that uses the plastic pipes, a monochromator, a detector, okay, and finally a display. Come on. So let's go and look at the first one, the halocathode lamp, the radiation source, Okay, we want to look at the radiation source. Normally the radiation is made, the name of that radiation source is the halocathode lamp. Okay, it's just a halo kosong, glass tube, and it contains the element that we want to detect. If we want to detect oxygen, it has to be made using oxygen. If you want to use to detect sodium, the element that will produce the light will also contain sodium. That's it. Okay, ini cerita dia lah. Also, we have the electrodeless discharge lamp. New machines uses this one, but it's quite expensive and we don't use it. Most of the time we use this halocathode lamp. Okay, this one is also being used, but not much. The next compartment, the next point that we need to know is the sample introduction system. This is the one that we have to pipe just now. We put our sample in a beaker. Okay, I'm sorry for the tone just now. That is a tone of somebody who are not confident. Okay, if we raise our tone at the end of our speech, means that we are not confident. That is how the Australian speaks. Sorry, Australian. But it should be at the end of our word in every sentences. Reduce the tone. You don't go. It should atomizer. Means that sometimes it's become a question. Sometimes it means that we are not very sure, or we are guilty, something like that. If we raise our voice, means that we are guilty of something. Okay, this is the sample introduction system. It's just a piping. It sucks a sample from a glassware or from a beaker and put it in the atomizer. Okay, atomizer will burn it. So what does it should have? What does the thing should have? Apa yang dia perlu ada? Okay, dia boleh sepatutnya. Okay, what it should do is it should have a reproducibility and efficient transfer. Means that every time it sucks the sample, it should be the same speed. Okay, and the same speed every time. That means that is what it meant by reproducibly. Sama je. And it should not have any interference. Okay, if we suck in something that contains sodium, and the plastic material that is being used to suck the sodium should not interact with the sodium. It should not be sodium plastic afterwards. Okay, boleh faham? Dia sedut air yang ada garam, dan sampai di atomizer tu air yang ada garam. Bahan penyedut dibuat daripada plastik. Tak sepatutnya yang sampai di atomizer garam yang mengandungi plastik. Itu maksud dia. There should be no interference. And have no memory. Means that if for the first analysis we want to measure sodium, so our sample contains sodium. The next analysis we want to measure something that contains aluminium, for example. So there shouldn't be any sodium in the aluminium sample. Not because of that sample itself, but because of the carrier. Okay, the piping. So it should not have any memory. Okay, and be independent means that it will not interact also. Okay, and it finally has to be universal. It can be used for any type of atomizer or any type of sample. Kalau macam cuvette tu tak boleh lah. Okay, this is how it looks like. This is the piping just now, and it goes in here. The gas will mix with the sample, and then the gas also will carry the sample into the atomizer, and it will burn here. Okay, this is the sample introduction system. It's like a straw, and our mouth is here. Okay, we suck the sample in, the water in, and then our mouth is here. We do the mixing using our tongue, and then we swallow. But here, okay, it will be burned here. There will be a small opening here, small opening. I think the size of an A4 paper. Okay, not the thickness of the A4 paper. I think the size very thin. Okay, and just like I mentioned before, aerosol. This word aerosol. Okay, when it goes up here, when it's been burned, if the sample contains either sodium, either magnesium, those elements will not be burned. They will be in ion or in atom form, or will be in the aerosol, suspended solid. Okay, and then they will also still be burned, okay, until they become ion. So please remember this one: aerosol, oxidant, and fuel. These three are being burned. Aerosol is the sample, oxidant is the fuel, the things to be burned that helps the burning process. Fuel is the thing that we will burn. Tiga benda. Oxidant normally is the oxygen lah. Okay? Fuel is the, in this case, is gas. Okay? So we have looked at the first one is the radiation source, and then we go to the sample introduction system. Then this is the third one, the atomizer. Okay, atomizer will burn all those aerosol plus fuel plus oxidant and make it into a smaller form of element, ion. Okay, everything has to be burned. If they cannot be burned, they cannot be measured. Or if they burn until there's nothing left, they also cannot be measured. Okay, we have four types of ways to vaporize the sample. We can use this oven, we can use electric arc or spark, we can use ion bombardment, we can also use flame atomization. The one that we've seen just now is the fourth one, flame atomization, where the process of making ion, making atom, and also producing ion is made using fire, using flame. Okay, what we need to remember, there are four types. There are four. Four types of vaporizing technique. Okay, flame, ion bombardment, electric arc, and oven. What about other three? You can read about it, but the one that we are using is this one. Okay? So what happens in this process of ionization process? First, just like what that lady mentioned, nebulization. Nebula means making droplets. That is nebula. I think everybody have heard that word, nebula. It means making droplet. You put your hand inside a glass of water, contain water. That glass contains water, or you dip your hand in a bucket of water. When you take out your hand and then you sprinkle it, okay, the process of sprinkling will produce nebula. Okay, sprinkling is also a nebulization. But in this case, it uses a small opening, just like when we use pipes to water the plants. Tapi musim hujan kita tak buat lah kan. Water the plants. We want to make sure that it goes further, not just near us. We want it to go further. So we reduce the size of that water pipe opening, isn't it? Make it smaller, and then that water will go further. Okay, we increase the pressure actually, but the water will be small and you can see some droplets. That is also nebulization. So in this process, that the sample that has been sucked in, that has been mixed with the aerosol with the oxidant, will be sprayed up in the arc or in the flame atomizer in a nebula form. So that is nebulization. So it's easier to be burned. Nebulization. After that is dissolvation, masuk semula, and then volatilization, making it volatile. If the sample is not volatile, we have to mix a volatile oxidant, and finally it becomes ion. Okay? Normally, we need to remember these first 3 steps: the nebula, the dissolve, and then the volatile. That's it. Yang lain tu boleh masuk sekali. Remember that word, nebulization, making droplets. Where does this happen? In the atomizer. Okay, ni yang saya cerita tadi lah. Okay, nebula, become droplets, and dissolution masuk semula dalam gas tu, dalam mixture, mix in the mixture, and then it will be burned, will be volatiles. Done. Okay, this is, I think, a better schematic diagram here. So we have a sample here, you put it in a conical flask, and then it will be sucked. This is the first stage just now, the second. First or second? The sample introduction system. Okay, it will be sucked and then mix the